Hey guys, I'm going to show you the 555 timer audio modulated plasma speaker circuit. I've got this successfully working, so I'm going to go ahead and publish this. Alright, first off I want to note we're going to power the 555 timer and the coil off of different power supplies, because these are only rated up to about 15 volts maximum and not a lot of amps. So we're going to run this on a very low voltage. Right now I'm using two 18650 batteries to run that. And then right now I'm using a 12 volt car battery charger. I have a transformer to use. Right now I'm waiting for a MOSFET to come in the mail. This is a TIP 3055 transistor that I'm using currently. I'll show you the plasma speaker working here in a second. But the MOSFET I'm ordering, I don't remember what it was, but it can handle a lot more amps, and I have a beefier transformer that I'll eventually use for this. But another thing I want to say is the negative outputs for both supplies go to ground. All grounds are common. So you got your transformer right here, you'll take the negative of that transformer, and then you'll take the negative of the battery and connect those together. And that way the 555 can signal the transistor or the MOSFET to turn on. So here's how to connect it. Alright, what we have is pin 1 on the 555 goes straight to ground. Between pin 2 and pin 1 there will be a 10 picofarad ceramic disc capacitor. These can be identified because on the ceramic disc capacitor it'll just say 10. And then the 2 pin gets connected to pin 6. Now pin 6 goes to a potentiometer. I'm using a 500 kilo ohm potentiometer between pin 6 and pin 7. And then I forgot to write them on here, but between pin 7 and pin 8 is a 15 kilo ohm resistor, and then pin 8 goes straight to positive. Pin 4 goes straight to pin 8. Pin 3 is the trigger line, the signal line for your power silicon. Pin 5 goes to the positive output of an audio amplifier, and then the negative output of the audio amplifier goes to ground through a 10 nanofarad capacitor. This is also a ceramic disc capacitor that I'm using. You can find these by the ceramic disc capacitor will have a marking 103 on it after the capacitor goes to ground. I tried hooking it up straight to the cell phone. I was getting some kind of weird things. My phone's acting funny and also wasn't loud enough. So I do recommend that you plug this up to some kind of amplifier. And then this is pretty much straightforward. You got the positive coming in one end of the coil of your flyback, and that goes to the collector, and the emitter goes to ground. I'm going to show you the windings that I use for this. Let's see. Alright, so this is wire I got at Home Depot. If I can focus in. It's just a standard wire. Not sure what gauge it is, but I got it at the Lowe's. It's pretty much this. This is what it is. It's just this double strand lamp wire for rewiring lamps, and all I did was I just cut it in the center and split the wire into one wire. Alright, so now let's go into here and I'll show you the setup. Here's my flyback transformer with the wire wound around it. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 turns of this wire on my flyback. And notice that it is wound clockwise. And here's what I'm using for the power supply, just a battery charger. Tells me the amps it's pulling. This pulls about 2 amps when it's working. And I have these massive 75 volt capacitors. Each one is 10,000 microfarads. So there's 75 volt total voltage and 20,000 microfarads. That's just to smooth the signal out. And then when I use my beefy transformer over here, I have a full wave bridge rectifier on here. Okay, so now we've gone over that. Show you. This is my massive heatsink I'm using. Right here, you can see it's the T220 case. And I got this at Radio Shack, along with the 555 timer. Here's the 555 timer circuit. And here's my 18650s. And this is what I was talking about, the ground. See how on the emitter I have this extra wire? This is the negative wire coming from the power supply. This extra wire I have is what connects the grounds to each other. I have it grounded right there. So everything shares a common ground. Alright. Oh, well, my phone's not sitting over here. Well, I'll show another video of it playing. I thought my phone was still sitting here, so I don't have any music to play at the moment. But here I have this little small audio amplifier. This was from some computer speakers. It doesn't work too well because to try to get a loud volume out of the spark, you have to turn this all the way up, and since it's a very low power, it distorts very easily. And I have a transformer and a rectifier on there and some smoothing capacitors to smooth the DC signal. What I can do though, I can't play music, but I can fire it up for you. And the idea of the plasma speaker is you want it to oscillate at the right frequency, so the spark is almost silent. Getting a little bit of electrical interference from somewhere. Probably because the amplifier is still plugged in and on, and my audio jack's just floating right here. But yep, that's it. If you have any questions, drop them in the comments. Oh, here's a failed Tesla coil I was working on. See, for this length, it's almost 10 inches, and it's only half an inch in diameter. I actually accidentally made that 555 circuit. That was my original plasma speaker circuit, but I was getting static from, you saw in my other videos. I was making that one to oscillate in the megahertz range because I calculated out. This thing supposedly is supposed to resonate at 1700 kilohertz. That's 1.7 megahertz. So I was trying to make a driver for this, and it just failed. I probably would use it for a crystal radio antenna. But yep.